Hey, physics, Josh here. Let's talk about forces today. A force is an interaction between two.
Sorry about that. So yeah, forces. It's an interaction on something that's going to cause a motion. And so Newton described this in his second law. And the second law was force equals mass times acceleration. And so what happens when you have multiple forces acting on one object? Well, what you do is you add them up together. And so there are tons of different forces, and we're going to go through some of them today. So let's start.
Whoa, did you feel that? I felt it too. That was gravity. Gravity is what holds you down to the center of the earth. The equation for gravity is force times mass times gravity, the acceleration of gravity that is, which is 9.81 meters per second squared on Earth. It's also pointing down all the time. So let's see what holds you up.
Yeah, so what holds you up, it's called the normal force. I'm sitting in this chair and I'm pushing down with gravity. The chair is pushing up on with a normal force equal and opposite to what gravity is on me. There's another force that can be used to help us out with holding things up called tension.
So tension force is anything that's going to be applied by a rope. So Josh is pulling on my chair through this rope. And so tension forces can be used vertically in order to counteract the gravity, but it can also be used horizontally. And so even though there's a force on my chair right now, I'm not actually moving. And this is because of static friction. Static friction only does enough to counteract whatever forces are going on. But as the force gets higher and higher, soon static friction won't be able to contain it. It'll be too much, and you'll hit the max of static friction, which is the coefficient of friction times the normal force. And so as that is hit, then you transition into kinetic. So now that I'm moving, we're now entering into kinetic friction. And it's the same equation as static friction, but with a different coefficient. And so now the kinetic friction is also trying to slow me down and not let me move, but the tensile force is just too strong.
That's enough about ropes. Let's talk about springs. Yeah, so springs. We're gonna use a cannon to show this. Inside this cannon, there is a spring in it. And as I push down, we are compressing it and adding energy to it. And when I pull this trigger, the ball will shoot up because of the release of energy. And this is called a spring force. That was pretty dope. Let's see how high it can go. 1, 2, 3.
So let's review. First, we have Newton's second law, which is force equals mass times acceleration. And so because Newton was the guy who came up with this, right, we call the unit of force a Newton. All right, and then also, when you have multiple forces acting on an object, right, that's the net force. When you add them up, you get the net force. And so net force equals the summation of all forces on an object.
So the first force we talked about was gravity. The equation for it is force equals mass times gravity. And G equals 9.81 meters per second squared. And that's just here on Earth. And that's what keeps me grounded. Now let's talk about normal force.
So normal forces, right? And this is perpendicular to the force that's acting on an object up above. And the way that we described it was the opposite of the force of gravity on that chair, remember? And it's what holds us up. Now let's talk about the other one that we had talked about.
Tension. So tension could be vertical or horizontal, depending on, if you're holding something up or if you're pulling it from side to side. And so whenever we have something that is being held up vertically, the tension is going to equal the force of gravity, right? And so if it's vertical, it's going to equal the force of gravity because it's holding it up. But if it's horizontal, then it's just going to be the force in newtons of the pull. And that is tension.
So next was friction. And there are two types of friction: static and kinetic. Static friction is what stops motion from happening, and is only as much as needed until we reach the Fs max, which we can find by taking the normal force and multiplying it by the static coefficient, which is different for every object. Once this is reached, we start finding the kinetic friction, which is the normal force times the kinetic coefficient. This tends to be smaller than this, and the kinetic friction always wants to slow down movement. Think of it kind of like moving through molasses.
So the last force that we talked about was a spring. And its equation for a spring is F equals Ks times delta X, where K is the spring constant and delta X is the change in position of the spring, whether it's condensed or stretched out. So yeah, that's forces.